On behalf of 24HourAnswers.com, I welcome you to today's lesson. In this video, we're going to look at one example of a derivative of an inverse trig function, and these are your 6 derivatives of your 6 inverse trigonometric functions. Before you panic and think I have to memorize 6 derivatives, notice a pattern here. Over here we have sine, tangent, and secant. Over here we have cosine, sine, cotangent, tangent, cosecant, and secant. And notice the derivatives are the same except for the cos, cosine, cotangent, cosecant. We just have a negative with these. So if you can memorize these 3 and memorize what they pair up with, sine goes with cosine, tangent goes with cotangent, secant goes with cosecant, you can just remember to switch the signs over here. Now, these derivatives can be derived, but for the most part, I recommend memorizing these 3 and then memorize what they pair with and switch the signs. Now, down here in this example, we want to find h prime of x. I'm going to go ahead and rewrite this as inverse tangent of x to the 1/2, just rewriting that radical as a rational exponent. Good practice when you're finding derivatives. Now, here's where you want to be careful. We still need to remember product rule, chain rule, quotient rule, all that good stuff, but what's important about this problem is that we do have chain rule. Notice that we have a function sitting inside of another function. X to the 1/2 is sitting inside of this inverse trigonometric function. That's a good indicator, or yes, you must use chain rule here. Now up here, we're taking the inverse tangent of x. So the inverse tangent of x, if we were to apply the chain rule, if we come back and multiply by the derivative of x, we're multiplying by 1, right? Because the derivative of x is 1. That's why you don't even see that in the formula, if you will, for the derivative of an inverse trigonometric function. However, we have to come back and multiply by the derivative of x to the 1/2, applying the chain rule in order to find h prime of x. So therefore, h prime of x is equal to, we're going to copy this down, but instead of us plugging an x in right here, whatever you're taking the inverse tangent of, or any of these rather, make sure you plug that exact thing in right there. So therefore, I'm taking the inverse tangent of the square root of x. I'm going to plug that in, 1 over 1 plus the square root of x squared. And again, notice what I'm doing. Whatever I'm taking the inverse tangent of, I'm going to plug it in right there and square it. So I'm taking the inverse tangent of square root of x, or x to the 1/2. I'm plugging it into that spot that you see here, and I'm squaring it. Now let's apply the chain rule. We have to come back and multiply by the derivative of this function, x to the 1/2, and again, that is the chain rule. So the derivative of this thing is going to be 1/2. We pull the power down, x, and then we subtract 1 from this exponent, so therefore we get negative 1/2. And that is your derivative. But if you wanted to clean this up a little bit, I'm going to leave the 1 up top. That 2, I'm going to shoot down to the denominator because it is in a denominator. I'm just going to put it right here. This x to the negative 1/2, I can shoot that down to the denominator as well to make it a positive exponent. So I'm going to say x to the positive 1/2. And then I'm going to multiply by this stuff that we have over here. 1 plus, and let's go ahead and write this as a x, because the square root of x squared gives us x. This looks a lot better than this does over here, but again, all I'm really doing is multiplying some fractions. I'm leaving my 2 at the bottom. I'm shooting this down to the bottom as well, as you can see here, because I'm making that exponent positive. It's not absolutely necessary unless your instructor says, hey, leave your answer with positive exponents, and that's exactly what we've done here. Now, very similar to all of these other examples, we'll visit some more of these in future videos where maybe we have to do a product rule or a quotient rule to tackle some of these inverse trig function derivatives. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.